Hi, so in this demo, I want to go through network load balancing, and you can see in the diagram that from our last course I've made some modifications. Specifically, I've added server 03. So in order to pull this off without major reconfigurations, we want to keep a domain controller. So we already have that, we can continue to use it, and it's a lot easier for us to keep the same internal address space than to reconfigure everything back to the external network so we can continue to get updates. So with that in mind, it's good to keep server 01 as a remote access server and to keep everything internal. So that only left us with server 02, which was the domain controller. So one of the very first things you'll want to do is to go on to server 02 and run the command to make sure that there's no FSMOs left on this. So the first thing, netdom query FSMO. Okay, so if you run this command, netdom query FSMO on server 02. And this is to check to see what FSMO roles that you have already migrated in the last labs to this server. And you'll want to transfer those back to RWDC01 before you start anything. And once you've transferred all these back to RWDC, then you can go ahead and remove the Active Directory role. And when you start to remove the role, it's going to ask you to demote the server and reboot. And after you've rebooted, then you have to continue and remove the Active Directory role again. It doesn't just automatically do it. You'll have to remove it at that time. Okay. So netdom query FSMO, find out what's on here for the flexible single master operators and move them off to RWDC01, and then DC promo this down, remove Active Directory, and remove DNS as well. Next thing you want to do is to update DHCP, because in DHCP some of you would have added the DNS entry for server 02 as a secondary DNS. So you want to update the DNS option. Alright, so at that time you should have 002 added as a member server only and rebooted, and everything will be good. But you still need server 03, so you'll have to, the fifth thing would be to create a server, create a VM from the template of server 2012. And you'll want to check to make sure that there is storage space, so choose the appropriate storage. We're running out of storage on one of these storage arrays, but we have space on the others. And once you have that running, you need to modify it. So server 03, set the networking. So attach it to your internal network, static IP, and join your domain. Okay, so once you have that all done, you should be able to, start the lab. So all of this is required before you actually begin network load balancing. So let's say I already have this set up. I have server 03 already. I've set a static IP 192.168.0.8 on this one, on the internal network. I pointed the default gateway to my internal interface on the remote access server, and DNS on everything is set back to 192.168.0.10. So there's one more configuration. Once you have all of this, you're ready to begin network load balancing. Network load balancing requires a second NIC. It doesn't absolutely require it, but it's better to have a network interface that's on a private network between the two network load balancing servers. And this is for the heartbeat between these two servers, just to keep track. And if heartbeats are missed, then it'll remove one of the servers automatically. Okay, there's one heartbeat every second. And if it's missed for 5 seconds, then the server gets removed, which makes network load balancing significantly better than round robin and DNS, since it actually keeps track to see which servers are available. So I'll just open up the server. And okay, so I have multiple servers, RWDC. The server 01 as the remote access server, server 2 and server 3. This is my new server, and it's connected to my internal network, and this will act as the other network load balancing server. I've already joined it to the domain. I've renamed it. Everything's set. What I don't have is another network adapter for the internal private network. Okay, so you already know how to do everything else. I don't know that you have set up the networks in your virtualization course yet. You probably have, but if you haven't, this is how I know how to do it. So each server right now, if you click on the server that you're running your VMs on, you'll see an IP for each server. So you take a look and see which one you're running on, and just have it selected. Whoops. What have I done? Okay, so all of my VMs are running on Saturn. So I have it selected. If you click on Manage here for these tabs, and there's a networking option. And under the networking option, there are virtual switches. And you can see each virtual switch that's set up on that server. Okay, and you can see which VMs are attached to it. So I can see that I've got a virtual switch here. It's the internal one for the Bacon domain, and I can see which servers are on that. So it should be all of my servers are on that internal network. And this one, the very first one, is probably the external network, and I can see that the Canadian server 01, which is the remote access server, has one interface on it. So it's the only one that has external access. What we need is another virtual switch just for network load balancing. So there's an icon here to add host networking. I'll just click it. And it gives you the option for the kernel network adapter or physical NIC, but there's this one down here for virtual machine port group for a standard switch. That's the one we want, so select the last option. And give it a name. Oh, new standard switch, sorry. A new standard switch. Assign the adapters. We don't need any adapters because we're not actually connecting to the external network. We're just going to use this for internal communication between the VMs. Gives us a warning. There's no active physical adapters. So we know that. And now you give it a name. Name it after yourself, please, so that they show up in the list properly. And we'll know which one to remove later without interfering with each other, because you will see everybody's in the list when you go to select one. And I'm going to call it failover. We'll use this internal network interface for failover clustering as well in a later lab. So I'm just going to name it failover. We don't need a VLAN ID, don't set one. Click next, and finished. Okay, so it'll make that network interface available on that one server. It doesn't make it available across the different servers. Okay, so you need to do this on the server that you're using. And then go back to the VMs. I'll find the VM that I want to modify. Oh, Irish and Joel. I'll edit this. Okay, so I have one interface on the internal network. It's great, so I'll go down, select new interface or new device. Network, I'll just add it. And then I'll select the appropriate network, so there's Shane failover. Okay. In a moment, I'll have another interface here. Okay, so it's connected. Take a look at the other server. That's going to be another network load balancing server, and I'll add that interface on it as well. Give it a moment. Okay, so I have two interfaces on each of the network load balancing servers. If I go to the first one, okay, so this is server 2. Bring up the interfaces. You can see that there's the bacon.local interface and this other one. This is the new one. Just going to rename it so I know what it is. Put a static IP on it. This could be a different network. Could be the same network. Right, we're not using it for routing. Oops. You don't want it to overlap with anything that you're actually using, though. I'm actually using the one network, although my diagram says 0. So update my diagram. And I'm going to pick 192, say 168, just to keep it consistent on the diagram anyway. The lowest IP that I have here is 8, so I'll say 7. Network load balancing interface, and this one six, 7 and 6. This is server 3, so I've skipped over to the other server. I was using this server before and we're repurposing it, so that's where the name came from. Okay. All right, so this is server 2. It's going to add the network load balancing feature. Okay, so under features, go through the list, and there it is, network load balancing. Let's add that feature to this server. And I'll go to server 3, do the same thing. I skip it? There it is. Okay, so it's finished installing on server 2. Just wait for server 3. Good. Now you can begin the configuration on either one of the servers. It doesn't really matter. I'm going to go to server 2 and tools. There it is, Network Load Balancing Manager. Alright, so this is Network Load Balancing. Sorry. And you'll see that there's nothing configured by default. Network Load Balancing is really easy to be configured on server 2012. They've made it really simple. You just right click and say New Cluster. And it says connect to one host that is to be part of the new cluster. So I'll put in the local server name and I'll connect to it. And it sees two interfaces. It says interfaces available for configuring a new cluster, and this is the interface that users will connect to. So pick the externally facing interface. And it sees the IP that's on this one. It's going to have unique identifier of 1. It's fine. Default state is started. All the defaults are fine. It's asking for a cluster IP address to be shared among all the members of the cluster. So this is the IP address that you would inform clients of. So when you want to connect to whatever's being clustered, you connect to this additional IP. So this has to be a unique IP that's not in use anywhere else. So I'm going to pick 5. It's fine. So I go back to this diagram. So I have 6 and 7, 8, and 9 are all in use. So this would be the IP that's used across both of these. Okay, so when a client goes to connect, they're going to connect to the third IP address, .5, and nobody will connect directly to .9 or .8 anymore. So the cluster IP is .5, subnet mask, and they're asking for an internet name. So network load balancing .bacon.local. So I'm going to resolve NLB.bacon.local back to 1.5. And it's asking cluster operation mode, unicast, multicast, or IGMP. You can pick any of these, but it's important that you pick the same thing on each one of your NLB cluster servers. So it has to be the same. I'm going to go with unicast. And the port rules. So which ports do you want the NLB cluster to resolve to, or respond to, I should say. If you edit this, by default it's all IP addresses on the entire port range for TCP and UDP. And its filtering mode is multiple host single. And this is fine. This would be used if it's stateful communication. So you've got SSL configured and a client connects. They connect to the cluster, so you have multiple hosts, but then they connect to a single server within that host, and they stay connected to that one server until they're done their session. So you don't want the communication when they click on different links within the website to send them to a different server in case there's HTTPS configured and you'd break that encrypted session. They need to maintain the session to the single server. So these settings are fine. We could leave it as this. If I remove this, it'll see the cluster IP, right? It doesn't see an IP address that's actually on the server. It's this additional cluster IP. And I can change this port. Maybe I'll just make it so that it's port 80. So I want to cluster port 80. Okay. So you can see it changes the text. It's .5, arrives on port 80, is balanced equally across all members of the cluster. Okay. That's it. Complete configuration for NLB on one server. Just give it a moment to register. Okay, so now it's done. I have one server that's part of the cluster. Now you don't have to go to the other server. If I go over to the other server 03 and I have network load balancing installed, and you can see it actually doesn't see anything in the cluster. It's not connected right now, but you could connect to an existing cluster and see the information. But there's no need to manage it on this specific server. You can do everything from the original console. So I'm just going to add a host to the cluster, and I want to add that other server to this cluster. So I'll put in the name. Pick the external interface again. Unique identifier of 2, it's fine. .8, it sees the IP, default state is started, it's great. Define port rules, and you can see that if I edit this, it's all grayed out, it's the same rules that were used before. It's part of the same cluster. So you hit finish, and it registers the second server as part of this cluster. So the only thing that I'm load balancing between the two servers is HTML, right? The HTTP website. And the servers themselves don't do anything other than split the traffic between the two servers. So because there's no shared storage, whatever we put up as a website has to be identical on both servers, and you have to synchronize it manually between the two servers. So this is only really good for a front-end web server that sends traffic to a back-end for retrieval. Okay, so now I have two servers as part of the cluster. Now, this resolves to nlb.bacon.local, so we'll have to edit DNS to add that record. So I'll go to RWDC. Open DNS. And I'll create a new host record. NLB 192.168.1.5. Add that host. I don't have a reverse lookup zone configured. So now NLB resolves to 1.5. I'll just test it. Oh, I should say ping NLB dot bacon local. It responds properly, which is great. If I do an ARP -A, I can see the MAC addresses. And there's 1.5, 1.8, 1.9, all with the same MAC. Okay, so that works. Now, if I want to test it, I've load balancing port 80, so I would have to be able to bring up a website and put an HTTP NLB dot bacon.local. That resolves back to 1.5. It should show me website, but I don't have a website configured on these two servers. So to truly test the NLB cluster, I need to install IS on both servers. Go ahead and do that now. I'll go to the other server, do the same thing, just so we have something to test the cluster. Okay, so IS is installed. And if I test it on the local machine, IS, when you install it, puts up a default page. Right. Okay, so the default IS page responds. It's in the inet pub directory. Right, so the easiest thing for us to do to test this, and I like easy, let's just create a text document in here. We'll have to view file extensions. Rename this default.htm. And we'll just edit this in Notepad. Just something that signifies that you've connected to this specific NLB host. Let's refresh this, and so that works. Do the same thing on the other server. Okay, so this is server 3. Go to inet pub, www root. Change the view. So you can see the file extensions, create a new text document, call it default. The name is important. There's default documents in IS. Default.htm is one of the default documents, and it's higher in the list than IS start. If you name this HTML, it's not going to work as a default document. It's not on the list. So it has to be default.htm. Notepad. Okay, so I just wrote host2, just so we can see whether we were redirected to one host or the other. Once you're sure this is working, you would put the same content on both servers. And that way, if you shut one down, users can't tell the difference, which is the whole point with a cluster, right? Just test that that site responds. Good. So we'll go back to a third station, nlb.bacon.ca. So I connected, when I refresh that time, to host 1. Now, as many times as I refresh, it'll probably still likely give me host 1. Let's go to a Windows 8 machine. Okay, so this time I get host 2. Right? So the cluster is working. You would also want to change this NLB to something that signifies a website. So you go back to DNS. And that's just easy as creating an alias. So www.bacon.local, send traffic to the NLB cluster. So I'll select NLB, the host that we created earlier. So anything that goes to www.bacon.local, send them to nlb.bacon.local. Test that. Okay, so it goes to host 1. If I go to my Windows 8 machine, it still sends me to host 2. Great. So that's an NLB cluster. Other than that, if we go back into the cluster manager, we could add a third host. That's something we could do. We can remove the cluster. There's cluster properties, change the IP address or add IP addresses that are allowed to connect. Select specific IPs, change the operation mode, port rules. You can add additional port rules. So let's say you want to listen to the same IP, but we added SSL to the site. So we can just change this to be the SSL ports. Now it load balances both 80 and 443. Okay. Updates all the servers in the clusters for you. There's control hosts. You can start, stop them exactly like it sounds. You're going to start or stop the this NLB service. You can suspend, like pause and resume, and there's this drain stop. What drain stop does is that it just doesn't allow any new connections, but doesn't stop the service until everybody's disconnected. Once the last user disconnects, then it stops the service. And there's the ports that it's listening to. There's really nothing else to be done. If you want to get rid of a host, you can select it, stop the service on that host, and then delete it. And it removes the configuration from that server. If we go to the other server and we want to see the configuration from it, you can open the load balancing manager and you can see the configuration. It's the same, right? That's it. That's as complex as network load balancing gets.